Okay, so today's question is to do a hyperboloid of revolution. Okay, so there's a few methods of doing this, but we're going to use this construction method. So this is basically just a hint to give you an idea of how to remember how to do it again. So basically we have a 100 millimeter high hyperboloid revolution, and then we have a 25 millimeter base. So for the minute we're going to ignore this curved base. We then have a 100 millimeter diameter and then a 66 millimeter diameter. Now it is going to be a little bit tight for space, so we're going to keep it as close to the top as possible. So the first thing we're going to do is we're going to set this up. Now, what I did here basically was I put an axis on the page in order that it would fit. So I'm hoping this is correct. So what I'm going to do is I'm going to mark out 50 here for my compass and mark out 33. Okay, so obviously we have to half the diameter in order to draw the radius, or to set the radius. So it'll be 33 instead of 2. So what I did was I measured from there to there is 33, half of 66, and then half of 100 is 50. And we'll draw these. And if we look, we see there's no hidden detail, and the reason there isn't in this case is because the vase must be glass, or well, it's open basically at the top. And then, so we can draw that fully. And ideally we do it as heavy as we can in one go, because trying to get it exactly on top of it again was going to be difficult. So we've got drawn out. So we have our plan drawn in. Now we need a space of 125 here, so it'll just about fit. So we won't need more than 10 millimeters. So you can see my axis is there. It should come out on your page, but just in case, well, just because you probably won't be able to see them with the visualizer, I'll just go across them. Okay, and I'm going to leave a gap of about 10. And my ground line, which often people forget to do, is a heavy line. Okay, so I'll draw my ground line like so. Okay, so we're happy enough with that. So we'll come up our 25 for the curve, or the sort of rounded base on it. And this is going to be the base at which our bit starts. So we're going to have 100 then. We'll put a little dot for that there. And we'll come up 50. Okay. So we'll draw this line across. We'll draw this in. Okay. So what we're going to do now is basically we're going to bring up this line like so, and this line. We're not going to bring up the center line. The reason I find that is because a lot of people sometimes get confused where V1 and V2 is if they bring up the center line. You can see from this construction here, the center point is actually a little loose. Apart from you could draw it as a center line just to show that it's symmetrical, but other than that, it's not needed at this stage. So the first thing we want to do is we want to locate the two vertices. So as you can see here, and you can use this for a reminder, this is V1 and this is V2. The next thing is we need to split these into equal parts, right? Now typically we would pick 5 because it's a nice easy number to do. So what I'm going to do is I'm going to draw it out and use the division line method, but I'm not going to bother splitting this. This is 50. 50 divides by 5 evenly. So that will come out 10, 20, 30, 40. Hopefully they can be seen there. Okay. So we're happy enough with that. And then this is, what would that be? 33, 17. 17 doesn't divide by 5. So in order for us to get full marks, we'd have to do the division line method. Now I might do it up here so that it doesn't interfere with my base. So what I'm going to do is basically I'm going to do 5, 15, or 5, 10, 15, 25. And I'm going to draw this back here. Now I could use sliding set squares, or I could use my adjustable set square. I'm just going to use sliding set square method in this case. Okay, or as you can see I'm balancing on my t-square. So if you're balancing your t-square, the trick is just to make sure that your one edge of your t-square is tipped in like so. It makes it less likely to slide. So draw these back parallel. Okay, this is basically the sliding set square method. And we have our point like so. So we will just mark those in blue just so that you can see them. Okay, and I'll bring those down here. Okay, that will limit you both sides. I'll need to do the same on the other side, but I'm going to use a different method just for the other side. So I'm just going to do this side here as is. I'm going to show an alternative method for the other way. So I'm just going to get a sort of a teal color here, and I'm going to start with this. So the first question is, do I join the bottom ones to V1 or V2? And while we have this hint here, you won't have it on the day of the exam. So if you think about it, if I join these ones to V1 and these to V2, they won't crisscross. So it must be the other way. So I've never learnt a method as such. I just look at it, and if I accidentally drew it out even, it wouldn't make any difference because I could I should figure out that they won't cross afterwards. So what I'll do then is basically these ones will go to this. So my marker is a little bit thick, ideally for this, but you wouldn't be able to see it on the visualizer otherwise. Okay, so it's going to be hard to see the individual points. I don't think I have a thinner pen here that I can use. But basically, we'll number these. We won't draw a line from 0. We'll go 1, 2, 3, and 4. 1, 2, 3, and 4. So we're 1 and 1 cross gives me a point. We're 2 and 2 cross gives me a point. 3 and 3 cross gives me a point. Or 4 and 4 cross gives me a point. So as I said, they're a little bit squashed there, but hopefully you can see what I'm doing. And hopefully if you can't, you can see it a little bit better from this. And we do the same here. Okay, so these are just our 10 apart, 10, 20, 30, 40. These ones will go to V1. Okay, and these ones here will go to V2. Okay, so again they're a bit thick and my marks are a bit funky, but hopefully you can get the general point. So 1, 2, 3, 4. Okay, and we sketch it in like so. Okay, so that's basically that side done. Now you could do the same thing on the other side as they did here. That's perfectly acceptable. The other method, and it's a good idea to think about it, is this is symmetrical on one side as it is on the other side. So I'm going to just bring across them and then bring them up just to show you. So there's two axes of symmetry. It's basically symmetrical this way, so that's the opposite of that, and it's also symmetrical this way, so that's the opposite of that. So we'll start with this side and we'll bring these across. So let's see, maybe we might use an orange just so that it stands out. So if I bring this across, hopefully that orange comes out okay on the visualizer. I can bring these like so. Now I will actually bring up the center line because I need it for this. So this is basically the same as an axial symmetry. Okay, so whatever distance they are on one side of the line, they must be the same on the other side of the line. I'll just put in my pen here. And basically, we have this point, and we have this point. Okay. So while you could continue on using the same method as you did in the last on the side over here, the reason it's a good idea to get used to this method is because when you have a hyperboloid that's not the full shape, so in other words it's only part, so in other words say if this was cut off, you need to use the mirror method pretty much. There is another alternative way. So then the other thing you could have done technically is, I'll just use a red to show these, you could have also done the same mirror method here. Okay, so whatever distance they are to this center line, they'll be the same on the other side. Again, I'll take my compass. So this one here, get that off. This one here, get it off. Let's be careful to get the right line. A bit on 2 in that case. This one here, step it off, and this one here. So it's just an alternative way that you could have used a mirror method rather than using the same thing. And as I said, it is important just to be aware of it, particularly if the question had a cut off one of these, okay, that it wasn't the full size. So again, just be careful. This is a solid line here. This is solid, and we now have to draw the curved base. So we know it's radius 25. So what we'll do is we'll set our compass to 25, or we know this distance here. We'll set this distance here. Okay, because we know it should touch this. We'll swing that way. That gives me a center point. And when I draw that down, it should neatly cut off there. Okay, we'll do the same here. Sorry, that mark isn't, that mightn't be obvious. And we'll draw. And I suppose technically we should mark the point of contact, i.e. where exactly it's the ground. So just to make sure, in case we're in particular in the exam, we'll bring that down there. That's the exact point at which the base starts. Obviously we've drawn a ground line there so we can see it, but technically if we were to draw that line from there to there, we'd have that like so. And then it'd be no harm to put in the center lines that they show here. So maybe I'm just going to dark green and just to finish that off. And again, double check. Always make sure to check the question. So if I check there, I haven't headed in that line. So it is an area that I would potentially lose marks. So we'll just use a green maybe just to do the lines that they did in red. Or maybe we'll use a red because I haven't used it extensively here. So they basically did a center line. So it's long dash, short dash, long dash, short dash, long dash, long dash, short dash, long dash, short dash, long dash. And same here, long dash, short dash, long dash, short dash, long dash. Oops, a little bit of inaccurate there, my T-square isn't in perfectly. Okay, and the same. So. Long dash, short dash, long dash. And again, we could just use a bit of Titix or whatever just to highlight that. But that's the question done. Put our name and our date on it there, and that's it completed. Okay.